this. Good morning. Happy Thursday. All right. So, we'll pick up where we left off. Everyone's feeling good today. Good morning, good morning, good morning. That's great. We started talking about solving systems of equations last day, so we'll review that quite a bit and kind of finish that off. But before we do, I posted assignment 1 on Moodle. So assignment number 1 is on Moodle. And it is due on Thursday next week at 11:59 p.m. So I always do things due at midnight, but because midnight is confusing, I do 11:59 p.m. So you have the whole day. Assignment number 1 is due on Thursday next week. So I always give you at least a week to work on things. Oops, can't write at all. That was happening in my first class too. Thursday, January 28th at 11:59 p.m. All right, so essentially midnight. You don't want to leave it too long, but you've got some time. I want to do a quiz. I want to do a quiz on chapter 1. And what I was thinking was we'll do it at the beginning of class on Tuesday. So I'll give you time to work on it. It's just going to be kind of like a 20-minute timed assignment, essentially. Shorter, obviously, but you'll just have 20 minutes. And so what we'll do is I'll give you the first 20 minutes of class on Tuesday, but if you don't want to use that, it'll be open all day on Tuesday. So you can start it whenever you want. You know, if you're going between classes or whatever, then that's totally fine. But I'll give you the first 20 minutes of class in case you want to use that. And then you can do it at any time during the day. So quiz 1, which is going to be on chapter 1 on Tuesday. So I will give you the first 20 minutes of class to do it, but it will be open all day on Tuesday. It will be open all day on Tuesday. So whenever you feel ready to do it, whether that is at the beginning of class time or if it's not, then I just want to try to see if this works. If it doesn't work, then I'll change it. But for the next one, but for this one, I just want to see, because I don't want to assume that you're able, you know, people are working or whatever. So I don't want to assume that you're all available at the start of class on Tuesday. But so quiz number 1 is on Tuesday, and it's going to be a 20-minute quiz, 1 attempt. So make it count, and 1 attempt, timed quiz. Okay. 20 minutes. And it's just going to be, you know, 2 or 3 questions, nothing major. We haven't done a lot in chapter 1, but it is so important that we talk about chapter 1 because there's a lot of key math components in there, fractions and BEDMAS and that kind of stuff. So you'll only have one attempt to do it, and it's just going to be a quick little quiz. Okay, so I'll give you the first 20 minutes, and then if you want to get it over with, then do that. If not, come to class 20 minutes after we usually start, 10:20. Okay, if you do have a question or any questions about the assignment or the quiz, let me know. I'm not going to get you to submit any work for this because it's just chapter 1. I don't really need to see any work here. I'll get you to submit work later for harder questions, just so I can make sure that your math is sound. But for this one, I don't need you to submit any work. It's just going to be the grade you get on the quiz and on the assignment. All right, so for a little bit of review, I haven't seen any questions in the chat, so hopefully that's pretty clear, but if not, let me know. A little bit of review. It was just on Tuesday, so we don't need to do a ton of review. In fact, I can't quite remember. Oh yeah, we talked about expanding and factoring. Can't remember what we did, but if we finished fractions last day, let me go back and just have a peek, because oh yeah, we finished fractions. Which we'll need to be able to deal with. We also talked about expanding and factoring. Expanding is usually pretty fun and quite pretty simple, right? Because you're just expanding an expression. Factoring can be a little bit tricky, where we pull out common multiples and we try to extract it to try to compress an expression to be as small as possible. So factoring can be a little bit tricky, but like I said, after factoring, you should always expand it back out to make sure that you haven't changed the expression. So we talked about expanding and factoring, and then we moved on to solving systems of equations, which we just introduced. So instead of doing a review question, we'll just pick up and we'll start over on that one question that we left off on, but you might have worked through it, right? If you were feeling kind of keen after class, then maybe you worked through it on your own, and maybe you have a solution already. That's great. But remember, when we're solving systems of equations, we're trying to solve, so a system of equations might look like (4x plus 2y). So I'm going to use the same system that we introduced last day. Is equal to 8, and then 2x minus y is equal to 7. Now, as a note, right, solving the system means finding an x and a y. So an x and a y, the same x and y that I can put into each of these, and both of them make it true, or both of them are true statements. So it means finding the xy point that satisfies both of these equations. So solving the system means finding an xy point that satisfies both equations. Okay. So what we're going to do is there are kind of two common ways of solving systems of equations. I'm just going to show you by substitution. So that's where we started off last day, or we kind of got to last day. You can also do elimination, but I find that it's very kind of tricky if you haven't worked with matrices before. So I don't want to do that. The textbook goes through and shows you how to do it, right? But there are two ways to solve a system of equations. There are two common ways, I should say, common ways of solving systems of equations by substitution or by elimination. I use substitution. The textbook also covers by elimination. All right, so if you're curious to know what by elimination looks like, then it's in your textbook. So I use substitution. The textbook also covers by elimination. Okay. So for us, I'm just going to stick to one way of doing things, but if you want to, or if you're curious about the other way, then go for it. So by substitution, what we mean is I'm going to solve for one of these variables, right? So I'm going to solve for either x or y in one of these equations. And what we said last day is that it's actually the easiest way to refer to these equations is if I just number them, right? Equation 1 and equation 2, because then I can say weird stuff like I'm going to solve for y in equation 1. Right? And I don't have to list this whole thing every time. So what you want to do is you're going to solve for one of the variables in one of these equations. Then you're going to substitute it, hence by substitution. Then you're going to substitute it into the other equation. Okay? So to solve by substitution, one, and it doesn't matter which one you solve for, but there will be some that are easier to solve for and to use than others. Solve for one of the variables in one of the equations. Okay. The next step is to substitute that variable into the other equation, right? So you always want to put it into the other equation. If you put it back into itself, it's not going to get you very far. Okay? Then substitute that variable into the other equation. Okay. Then once you substitute that variable, you'll only be left with the other variable. Now that doesn't really make sense, but you'll see it and you'll say, oh, okay, yeah. Right. So then solve for the other variable. So in our case, right, what we established last day was, okay, it looks like the easiest thing to solve for is y in equation 1. So that's my first thing. So I'm going to rearrange this and have y on one side and everything else on the other side. Then I'm going to take that y and I'm going to substitute it in here, which means now I'm only going to have x's as my variable in equation 2, right? And so now I'm going to be able to rearrange and solve for x, okay? Then I'm going to have a value for x, which I can then go back and put in and solve for y, right? So then solve for the other variable, then use that solution to solve for the original variable. Okay. It's not really going to make sense. I don't expect it to really make sense until we've done the full example. So here we go. So if we have solve the system, and I'll use that one, 4x plus 2y equals 8, and 2x minus y is equal to 7. So just for some shorthand, I'm going to label these 1 and 2, right? And so my first step, step 1, okay. First thing I'm going to do is I'm going to, and here it's just going to take kind of a trained eye. So you'll need to do a couple of these, and then you'll start to see what the easiest thing to solve for is going to be, right? And so what we did here was we just kind of scanned here, and I could solve for x from 4x, right? Leaves me with 2 over 4y, which doesn't really look good. So that's why we landed on solving for y in equation 1. But you could, it doesn't actually matter which one you solve for, right? So just remember, it doesn't matter which one you pick, just it's easiest if you just pick something that's easy to deal with. So here, solve for y in equation 1, right? So I'm just referring to the equations by their numbers now. Here, I'll put in brackets. You can pick either variable from either equation. And just make sure that you pick something that's easy. So what we have is okay, well, equation 1 looks like this, 4x plus 2y equals 8. So now I'm solving for y, which means I'm going to have 2y is 8 minus 4x. Okay. Now solving for y, I need to divide both sides by 2. So I get y is 8 minus 4x divided by 2. Notice that I can factor out a common 2, and that's the only way that I'll be able to cancel this 2. So I'm going to physically show me pulling out that common 2 just to emphasize that that's what I have to do, right? And then as we get a little bit more confident with our cancellation, then we can just go ahead and cancel. But you have to pull out a common 2 from both of these terms because they're being subtracted. So y is going to be 2 times 4 minus 2x divided by 2. And I'll just use a different color to show that they cancel out. Oh, yeah. Gotcha, Roberta. Good. I'll try to slow it down a notch. Okay, so, right, making sure that you pull out this common multiple of 2 before you cancel it, right? Like I said, later on, if you see, okay, 8 divided by 2 is 4, and then do 4 divided by 2 is 2, that's totally fine, right? But for now, I'm just going to keep it as y equals 4 minus 2x. So, good. So now I have this equation here, 4 minus 2x, which I can use in place of y, right? And so that's going to be the key here is, okay, so now I can take y equals 4 minus 2x and I can substitute it into the other equation, right? And the other equation in this case is equation 2. Okay? So now step 2, I'll put it on a fresh page here. Step 2, substitute y equals 4 minus 2x into equation 2. Okay. So if we write out equation 2 here, 2x minus y equals 7. So equation 2 looks like 2x minus y equals 7. So what I'm going to do here, right, is this y is going to be replaced with 4 minus 2x, making sure you keep 4 minus 2x as its own thing, right? So you've got this negative outside that you'll have to bring inside. So you want to be really, really careful with your expansion here. So this becomes 2x minus 4 minus 2x is equal to 7. Okay, so now, right, being really careful with, I don't know why I wrote so little, being really careful with expanding this negative inside, right? And so we get 2x minus 4 plus 2x is equal to 7. Now I'm back on easy street, right? I have to collect like terms and I'm slowly going to solve for x, right? So I'm going to collect like terms and then I'm going to call it step 3 where I actually solve for x. So here I'll say collect like terms. And we end up with 2x plus 2x is 4x. 4x minus 4 equals 7. So we have 4x minus 4 is equal to 7. Okay. So now I'm calling it its own step. But if you wanted to just keep going and solving for x, that's fine. Step 3, solve for x. Okay. And that totally depends on, you know, if we had solved for x in the first bit, then we would have to solve for y in the next bit. But there's only going to be one variable here, so that's why it'll just kind of fall out. So if you have 4x minus 4 is equal to 7, solving for x here is kind of no big deal, right? I have to first add 4 to both sides, and then I have 4x is equal to 7 plus 4, which is 11. So then I have 4x is 11. Solving for x, I get x is 11 divided by 4. Okay. Good. Okay, so now I know even though 11 divided by 4 is not a nice number, it's still a number. It's 11 over 4. So now I know that x is going to have to be 11 over 4. Okay. So now what I'm going to do is now I take x is 11 over 4 and I substitute it, right? So this is by substitution. So now I substitute it back in to the equation for y, right? Which we established in the first step, y is 4 minus 2x, but now I have x must be 11 over 4. So now I can substitute that back in, and then I'll be able to solve for y. So now substitute, so step 4, substitute x equals 11 over 4 into y equals, oh, now I've lost it, 4 minus 2x from step 1. Okay. So now what I have to do is, okay, well, I am dealing with a fraction, so good thing we reviewed how to work with fractions, right? I have to have a common denominator if I'm adding or subtracting, but then I'll be able to solve for y, right? And so here I get y is 4 minus 2x, so y must be 4 minus 2 times 11 divided by 4. Okay. Keeping in mind all our rules for fractions, right? So here I'm multiplying two fractions essentially, right? I can rewrite 2 as if it's 2 over 1. 2 divided by 1 is just 2, right? So I'm not, you can never alter anything, but you can manipulate things. So we have 2 over 1 times 11 over 4. 2 times 11 is 22, and then 1 times 4 is 4. So what I have is I have y is 4 minus 22 over 4. Note here, right, to subtract fractions, we need a common denominator. Right. That's just from last day, where we really went through and talked about fractions and how we're going to deal with them. So remember the trick that we're going to use, right? So if I need a common denominator here, 4 I can rewrite as 4 over 1, right? Then it's a fraction. The common denominator that I'm looking for would be 1 times 4, so just 4. Then what I'm going to do, right, is 4 times 4 over 4 to force that denominator of 4. So y is going to be 4, and then I'll show it in a different color just to emphasize that that's the new thing that I'm doing here. 4 over 4 minus 22 over 4. Technically, I'm doing times 1 over 1, but I don't need to do that. I don't need to show that, right? It's not going to do anything. Now I'm multiplying two fractions and then I'm subtracting, right? So technically 4 is still 4 over 1 times 4 over 4. So 4 times 4 is 16 over 1 times 4, which is 4. Which makes sense, right? 16 divided by 4 is 4, which is exactly where we started. So you never want to alter anything. So y is going to be 16 divided by 4 minus 22 divided by 4. 16 minus 22, let's see here. I'll use this. 16 minus 22 is negative 6. I'll use our calculator next time. So then we have y must be negative 6 divided by 4. All right, putting him over that common denominator. I can simplify that a little bit, right? Negative 6 divided by 4, I can rewrite as negative 3 over 2. But if you wanted to leave it as negative 6 over 4, that's totally fine. I'm okay with that. But, right, or y is negative 3 over 2. They're the same. Okay. So, now what we found, right? So now we know that x must be 11 over 4 and y must be negative 3 over 2. So now I have an xy coordinate that should solve this whole, both of the systems at the same time. So what we have found is that when x is 11 over 4 and y is negative 3 over 2, okay, both of the equations should be true, right? Both equations should be true. Okay, so what's nice about solving systems of equations is you'll always be able to check your work, right? Make sure that what you found works, right? And so always check your work by plugging in these numbers into the original equations. We can always check our work. We can always check our work by plugging in the values of x and y, the values of x and y we found into the original equations. So if we go back to our original equation, right, that was 4x plus 2, I've got it here on the side, is 8. And then we had 2x minus y is equal to 7. Okay. You know what? I'm going to split these up and put them side by side so I can work them on the same page here. So that's what I'm going to do. I'm going to move this over. Oh, I'm just going to, let's just start that over here. So I'm going to put these so I can work them side by side. So 4x plus 2y equals 8. And then 2x minus y equals 7. So I just want to make sure that when I put in x is equal to 11 over 4 and y is equal to negative 3 over 2, I should end up at 8. Right? And then same thing here, 2x minus y, I should end up at 7. So let's substitute these in and see what happens. So I have 4 times, and I'm going to use a different color to show 11 over 4 plus 2 times negative 3 over 2. And I want to see, does it equal 8? All right, so I'll put a little question mark up top just to remind myself that they're not necessarily equal. I'm just hoping that they are. All right, so a little kind of sneak attack. You could go ahead and find common denominators, but what's really nice here is that this 4 is going to cancel with this 4, and then you don't have a fraction anymore. And because you can do it here on the other term as well, we can avoid dealing with the fractions. So here, right, I'm just going to show that this 4 cancels with this 4, and this 2 cancels with that 2. So what I'm left with is 11 minus 3. 11 minus 3 is 8. So that's good. So then I have 11 minus 3. Does it equal 8? 8 equals 8. Whee! Okay. So you just want to make sure that your solutions solve the system, right? So let's do the same thing for the second equation, 2x minus y is equal to 7. So I've got 2 times x again, I'm going to force to be 11 over 4 minus, and then my y is negative 3 over 2. Making sure you pay attention to those, the negatives there. Okay. All right. So a little bit of kind of scanning is going to show you that, okay, well, 2 and 4, I can't quite cancel, right? And there's nothing for me to cancel this 2 with. However, instead of trying to force a common denominator again, what I'm going to do is I'm going to cancel this 2 with 4 and just be left with 2 in the denominator. And then voila, I have a common denominator, right? So sometimes we have to be a little bit sneaky about it. And it's just because I'm lazy. I don't want to find a common denominator. The safest way is to find the common denominator, but usually what I do is if I'm just canceling, so technically what I've done is I've rewritten 4 as 2 times 2 and canceled one of those 2's. And then I just highlight that, okay, I'm left with 2 here. So what this becomes is I have 11 divided by 2 minus negative 3 divided by 2. And I want to see if it equals 7. So I'll put that little question mark up top. Okay. So now I've forced this common denominator one way or another. I'm going to force it. And then I'm going to have 11 plus 3, right? So 14 divided by 2. So 11 plus 3 divided by 2. Does it equal 7? It's looking good, right? So 14 divided by 2. Showing every step here. You can probably just, oh, what the, okay. The little dictation microphone is everywhere, I find. I always hit it by accident. So if you just went from 11 over 3, or 11 plus 3 over 2 to 7 equals 7, that's totally fine. Okay? But here I'm just showing you where everything came from. And so 7 equals 7. Great. So therefore, so now we've confirmed, right, that when x is 11 over 4 and y is negative 3 over 2, that is the solution to the system, right? We were only able to find one solution, and that's fine. Therefore, x equal to 11 over 4 and y equal to negative 3 over 2 is the solution to the system. Okay. Okay. So we did it. Okay. What I want to kind of emphasize is, because it's going to come up later, if you have equations, and I'm just going to scroll back to our original system here. Where were we? There. So if we have, oh, catching up there. If you have an equation and the only variables you have is an x and a y, and you don't even necessarily have to have an x, right? But as long as there's a y and an x, we call it a linear equation. And the reason for that is because it's going to make a straight line. Okay, so any equation, let's scroll way down. any equation that only has a y and possibly an x, so not necessarily an x. Any equation that only has a y and an x variable is called a linear equation. Okay, because we can rewrite it as an equation of a straight line, right? So linear just means straight line, and then linear equation is the equation of a straight line. So, so if you just have an x and a y, then you'll be able to rewrite it as a linear equation, or it is a linear equation. We can rewrite it in the form y equals mx plus b, which might sound familiar, right? Where m is the slope, right? Whatever is attached to the x is a slope, and b is the y-intercept. And this is the equation of a straight line. The equation of a straight line. So what we just did, right, was, okay, so our first equation was a straight line. Scroll way back here. Okay, so here I have an x. Oh, let it catch up. Here I have an x and a y variable. I can rearrange this and solve for y, and then I'll have something in the format of y equals mx plus b, right? If I rearrange and solve for y. Same thing here. So what we said was solving the system is actually finding the point of intersection, right? And so two lines are going to intersect, or they might intersect, and that would be the solution. Okay, so if you have a system of equations, of linear equations, right, the solution is the point of intersection. We go back here. So given a system of linear equations, and we're only going to deal with linear equations, so don't worry about that. It's true for other equations too, but we're not going to get there. So given a system of linear equations, the solution is the point of intersection. The solution is the point of intersection. So what I want to do is I want to show you an app called Desmos, and you might have worked with it before, maybe in high school, or if you did pre-calculus or something like that, maybe, or maybe even calculus, I don't know. But Desmos, it's just an online calculator, and it's just a free app that you can download, and you don't even need to sign in or anything, but it's especially useful for solving systems of equations, right? And so I just want to give it to you so you can have another way to check your work. Okay? So the Desmos app is this little green one with the wavy graphs. So if you go here, I was doing it for a different class. So what you can do is you can just enter the equation that you have. So we've got 4x plus 2y is equal to 8. So notice that, okay, so it confirms our suspicions that, yes, it is a straight line, And we'll talk more about linear equations, but we've got this downward slope, right? So now what I'm going to do is I'm going to put the other equation, 2x minus y is equal to 7. Okay. So what you can do, right, you see this point of intersection, oops, and it'll let you kind of expand and zoom in. It'll only give you the decimal approximations, right? So that's why I will want the exact answer is 11/4. But if you do 11 divided by 4 on our calculator, where's our calculator? Here. Oh, great. 11 divided by 4 is 2.75, right? And if you do 3 divided by 2 is 1.5, but it's negative, so negative 1.5. Which is exactly the point of intersection that we just found. Okay. So that's kind of neat. So you'll be able to check your work, but I do want those exact answers, 11/4 and negative 3/2. Okay. So now you have another way to check your work. Right? Let's do another example of solving a linear system. So example, solve the following system of equation. Oops, following system of equations. Okay. All right, so our system here is going to be 2x minus 3y is equal to 7. And my second equation is going to be 3x plus y is equal to 4. Okay. So again, I'm going to start by just labeling this equation 1 and 2, okay, just because it's easier to refer to. And then remember, our first step is to just kind of scan here, and we'll kind of step 0 in this case, if we want to refer back to what we just did, is okay, so my variables here are x and y, right? And x and y. So both of these are still linear equations. So I'm still finding the point of intersection of two lines, right? And so, so that's good. It doesn't really matter, but we always will be doing that, right? So you could put these right into Desmos and just kind of see what the solution might be. But then I do expect you to be able to solve these, right? I'm not getting you to show any work on quiz 1. So this will be on quiz 1, definitely. But on quiz 2, I will get you to show work, and we will be doing more of it. So might be worth getting in the habit of doing it properly. So what you're going to do is you're going to scan and just see, you know, what variable is the easiest one to solve for. In this case, this plus y is really jumping out at me. That's going to be the easiest thing to solve for. So let's go ahead and do that, right? Step 1, I'm going to solve for y in equation 2. Okay. So you just pick one. And like I said, if you want to make it a habit of just always solving for the first variable in the first equation and then putting it into the second equation, if you just want to have kind of a method that's always going to work, then that's fine. I just am lazy. So I'd like to pick the easiest one. So from equation 2, I have 3x plus y is equal to 4. So then solving for y, I get 4 minus 3x. Okay. Now I'm going to substitute y equals 4 minus 3x into equation 1, right? So not equation 2, because then I'm just putting it back into itself and that doesn't make sense. I have to put it into the other equation, right? So step 2, oops. Substitute y equals 4 minus 3x into equation 1. Equation 1 was 2x minus 3y is equal to 7. So now I'm going to replace y with 4 minus 3x. Now we have to be really careful because now I need to expand that negative 3 onto both 4 and minus 3x, right? And so this becomes 2x minus 3 times 4 minus 3x is equal to 7. Okay. And definitely kind of work alongside here and make sure that you're getting to the same results that I am, unless I screwed up at some point, but probably not in this section. Maybe later on, forget a negative or something. But then you can keep me honest. So you want to make sure that you're expanding this negative 3 inside both terms, right? Very, very important. Same as we said with the polynomials, right? We always want to pay attention. So we've got 2x minus 3 times 4 minus 3 times negative 3x. And I'm just showing it to emphasize that I'm bringing that negative 3 inside on both. If you skip straight to this next step, then that's fine. 2x minus 12 plus 9x is equal to 7. I'm not doing a very good job of stacking my equal signs, am I? Can easily be fixed in a cheating way. How about that? It's 2x. There. No harm, no foul. So, right, negative 3 times negative 3 is positive 9, and then times x, so plus 9x. So now if I collect like terms, I've got 2x plus 9x makes 11x, and then minus 12. So I have 11x minus 12 is equal to 7. My next step here, and if you wanted to just keep going and solve for x here, that you can combine those steps, right? But I just want to break it up a little bit. Step 3, solve for x. Okay. So from 11x minus 12 equals 7, I'm going to rearrange this and solve for x. So I'm going to add 12 to both sides, and then I'm going to divide both sides by 11. So I have 11x is 7 plus 12, which is going to be 19. So 11x is 19. So x must be 19 divided by 11. Good. Okay. So now I have a solution for x. Now, remember, we take that x equals 19 over 11, all these nasty fractions, but it's good to have practice with fractions, and that's why we had to cover them. So 19 over 11, is what I'm going to substitute into x from step 1, right? So here, y is 4 minus 3x, and we just said that x is going to be 19 over 11. So now I'm going to substitute it back in to solve for y. So step 4, substitute x equals 19 over 11 into y equals, and what did we say it was? 4 minus 3x from step 1. So y is going to be 4 minus 3x, but substituting that y, or x equals 19 over 11, I get 4 minus 3 times 19 over 11. Gonna get a little bit ugly, right? One thing that I'm gonna check first, in case I can avoid dealing with fractions, I will, but 3 over 11 doesn't simplify to anything nice, so that's a bummer. Same with 19 over 11. I don't see anything nice that I can extract there, so I'm stuck with this fraction over 11, which means what I'm going to do is I'm going to put 4 over 11. So 44 divided by 11, right? 11 times 4 is 44. So here I've got y is 4, and then I'm going to emphasize by saying 11 over 11 minus 3 times 19, let's see here. Oops. Mafia City, huh? I've never seen that ad before. It usually does the stupid homescapes. I don't know. Anyways. Now, I'm scared to go back and say what I was going to do. Oh, 3 times 19. 3 times 19 is 57. Okay, so I'm going to bring that back in here and rewrite 3 times 19 as minus 57 over 11. 711. 57 over 11. Okay, so I'm going to simplify this, right? I'm multiplying fractions. So 4 times 11 is 44. And then 44 minus 57 is all over 11, right? So we're getting better at dealing with fractions, more comfortable and just kind of a little bit quicker. So 44 minus 57, and then that's all over 11. 44 minus 57, I'll go back in here. And 44 minus 57, negative 13. So I have y is negative 13 over 11. I'll try to simplify that. I don't see any way to simplify it, so I'm just going to have to leave it as negative 13 over 11. So again, you can check your work by substituting the solution back into the original equations, right? But what I want to do is I'm just going to check it using Desmos instead, right? So you've got 2 options, 2 really good options for checking your work. So there's no reason to have wrong answers here, right? When you're solving systems of equations, you have ways to check your work to make sure that what you did made sense. So therefore, the solution to the system is x is equal to 19 over 11 and y is equal to negative 13 over 11. Because I know that Desmos only uses, it's only going to give me the approximation, right? So the decimals. So if I do 19 over 11, oops, wrong calculator. 19 over 11, I'm expecting to see 1.72727272, blah, blah, blah. So 1.73-ish. And then what was my other, it was negative 13 divided by 11. Negative 1.18, just so I know what to expect here. Okay. So now what I'm going to do, just to check my work, right? It's not part of the solution here. I'm done. I'm done this problem. In fact, I'll end it like that. Okay. But I am checking my work, right? So what I'm going to do is I'm going to go back to the original system, and I'm just going to graph these two lines in Desmos and find the point of intersection and see what happens. Hopefully it's the same as what we had. So our first equation was 2x minus 3y is equal to 7. Okay. And then our next equation was 3x plus y is equal to 4. Okay. And then you can click these. So it highlights all these kind of points of interest, which are just going to be the intersections, or the intercepts rather. And then here's our intercept, which 1.727 and negative 1.182, both of those look familiar. So we did well, right? And notice that the XY coordinate, usually we write XY coordinates as if they're ordered pairs, they're called. So let's write them like we would later on. We write the solution, sorry. We write the solution as an ordered pair, x comma y in round brackets, to indicate that it's just one point, right? It's one point on an XY grid. So to indicate it is one point on the XY grid or XY plane, it's called, right? When we do our X and our Y axis, and maybe I'll just do XY as one there, XY plane. Okay. So our solution should be, we would write as 19 over 11 and negative 13 over 11. And you can do kind of big round brackets like that. But for me, if you just want to write x equals and y equals, that's totally fine, right? But just knowing that it is one point, and you can write it as an ordered pair, and we'll talk more about ordered pairs later, right? But an ordered pair is just one point. Okay. So there are two other options for the solutions. Now, let's see here. I guess in general, there are three solutions. One is we were able to find a point of intersection, right? So there are three possible outcomes when solving a system of equations. The first one is we're able to find a solution, right? So we're able to find the point of intersection just like we did above. So we are able to find a solution as we did above. The other option is you might have infinitely many solutions because the lines are on top of each other. Okay. We could find infinitely many solutions, infinitely there. I have to spell it out. We could find infinitely many solutions if the lines are on top of each other. Right? So if we've just got the same line, then we find infinitely many solutions. And how that's going to come about is when you start to solve the problem, just like we did earlier, if you come across just a true statement, right? 2 equals 2, for example, that's going to be true regardless of what XY combination you put in. So, so this is going to be if you find a true statement such as, and I'll do an example, such as 2 equals 2, right? Then you'll have infinitely many solutions because it doesn't matter what X or Y you have, 2 will always be equal to 2. The other option is if your lines are parallel, completely parallel, right? They'll never intersect. Okay, so then there will never be an XY point where these two intersect, and that can happen, right? So our third one, we could find no solutions if the lines are parallel. Okay. And kind of in terms of how we're going to solve these, right? If you find a false statement, such as 4 equals 2, then you have no solutions, right? Because there's no XY combination that's going to make 4 equals 2 true. Okay. So if you find a false statement, such as 4 is equal to 2. I'll do an example of this second one, right, where you have infinitely many solutions, and then you'll see what I mean where you would have no solutions, right? So showing you one is gonna give you an idea of what to expect for the other one. So for an example, find the solution to, so we've got 2x plus y equals 4 and x plus 1/2 y is equal to 2. Okay. If you're really kind of on the ball here, you would see that these are the exact same, right? These equations are the same, but let's say you don't recognize that, right? If you multiply 2x times 2 times 1/2 is 1y, 2 times 2 is 4, right? So then you're back at this one. But let's say you don't see that, because I don't expect you to see that, right? So let's say this is my equation 1 and this is my equation 2. Just as we would normally, right, I'm going to pick one of the variables to solve for, right? And the easiest one I see to solve for here is going to be solving for y in equation 1. Because if I solve for x, I'm going to have to deal with this 1/2 y, which is not that fun, right? So I'm going to solve for y in equation 1. So you go on, so you always start the same way. And then what you'll find is, oh, I can't go any further. Step 1, I'm going to solve for y in equation 1. So I have 2x plus y equals 4, which means y is going to be 4 minus 2x. Then my second step, step 2, I'm going to substitute, right? This is our third one, so I'm going a little bit faster. I'm going to substitute y equals 4 minus 2x into equation 2, right? Just making sure you don't put it into equation 1 again, because you won't go anywhere. Substitute y equals 4 minus 2x into equation 2. So equation 2 is x plus 1/2 y is equal to 2. So x plus 1/2 times 4 minus 2x is equal to 2. You could simplify 4 minus 2x, good call. Ultimately, it doesn't really do anything for me, but it is good to be able to recognize, right? I could pull out a common 2 here and have 2 times 2 minus x, right? And then that'll help me simplify here. Or if you prefer, you can pull this 1/2 onto each of these. You're doing the same thing either way, right? But really good if you pull out a common 2 and then you're able to cancel with this 1/2. So you have x plus, let's do what was suggested here, 1/2 times 2 minus x is equal to 2. Good. Okay. So now I've got a multiple of 2 that I'm able to cancel here. So I'm going to cancel this 2 with this 2 and say, okay, x plus 2 minus x is equal to 2. Hey. I'm going to end up at that 2 equals 2 situation, right? Because x minus x is going to go away. So then, must have gathered that when I read my notes or something. So now, right, x minus x is going to go away. And I'm just left with 2 equals 2. This is a true statement, which means, okay, I can't go any further, but it also means that regardless of what x and y values I put in there, it'll always be true, right? So I have infinitely many solutions. So we can't go any further. But since this is a true statement, we can pick any values of x and y. So we could pick any value of x and y, and the system would be true, and the system would be solved. Therefore, we have infinitely many solutions. Therefore, we have infinitely many solutions. Okay. Good. So, same idea, right? If you landed here at the end and you had a false statement, 0 equals 2, for example, then you have no solutions because that's always going to be false, right? So kind of by the same logic, it doesn't matter what value of x and y you put in there, it'll always be false, and so you'll always have no solutions. Good. Okay, so I know that was a lot. Section 1.5 is a lot, but it'll definitely come up on our quiz on Tuesday. So make sure you practice those, and there are exercises for you to try in the textbook. And remember, the textbook has solutions in the back, so so you can always work through those and practice. Okay, let's move on to, and I'm just going to pull up, and I know I'm riding you guys hard today. This is still in chapter 1. So, but it does come back in chapter 2. So we will be solving systems of equations in chapter 2 as well. Cool. Let's see here. Make sure I covered everything that I wanted to before we go into percentages. So moving on to section 1.6, which is the last section in chapter 1. I'll put it on a fresh page here. Section 1.6 is on ratios, percentages, or proportions. Ratios, proportions, and percentages. Yeah, the quiz is going to be a Moodle quiz, and it's just going to be one attempt and just close after 20 minutes. So it's a little bit, it'll be similar to the assignment, but just quicker. Hopefully more painless, less painful. Awesome. So section 1.6 really just goes through and emphasizes, okay, ratios. For us, what's more important is talking about proportions and percentages. So I'm going to skip straight to that. One important thing is a proportion is a percentage, right? It's just the decimal version of a percentage. So a proportion is a percentage in the sense that a proportion times 100 is a percentage. Okay. Now in math, right, if I say 60%, right, so 60%, you can't use the 60%. You have to use the proportion of it, right? Which means you have to divide by 100 to get to the proportion. So in math, we always use the proportion instead of the percentage. but it's tricky because we usually talk about percentages. So although we usually talk about percentages, in math, right? So in all our calculations, we have to use the proportion in our calculations. So in math, we must use the proportion in our calculations. Okay. So that's going to be really important, especially when we're talking about, okay, so money is earning 5% interest. That's huge, I know, but 5% interest, if you're multiplying by 5, hello, yes, please. You'd have to multiply by 0.05, right, which is 5 divided by 100%, or 100 rather. I think there's even a percentage button. There is here. So if I do 60%, right, and then I hit that percentage button, all it's doing is dividing by 100, right? And so what if I go back? Yeah, it just keeps dividing by 100 every time. So see here, this percentage button on your calculator. If you're ever in a jam, right, 52% is 0.52. That's the proportion. Especially tricky is 5%, right, 0.05. Okay. Jumped around, oops, there. So you can use that percentage button, or if you just divide by 100, then that's fine. So we'll talk about percentages, but we have to use proportions in our calculations. So that just means that the decimal version. Okay. All right. So let's say, just to get comfortable with percentages and proportions and all that fun stuff, let's say you're at a restaurant. Haha, yeah, right. I don't know if they're open here yet. It's just me, so I don't really see the point in going out, but I don't think they are yet. I don't know if restaurants are open in BC. Who can keep up? All right, so, but let's pretend. So at a restaurant, the bill is $45. Plus, or sorry, I should say before, just to emphasize that before 7% tax and a 15% tip, right? So notice here, right, we talk about percentages, but before we're able to do anything with these percentages, we have to convert them to the proportion, right? So we have to talk about 7% is 0.07 and 15% is 0.15. Seven percent is 0.07 and 15% is 0.15. And you can confirm it using that little button on your calculator or just taking 7 divided by 100. So what's the total? I guess I should finish the question. What is the total? I'm trying to keep it on the same line here. Okay. So what I'm going to do is I'm just going to kind of talk my way through this. And I think we can all agree that this is a pretty real life example here. I I think usually you end up tipping on the taxed amount as well. Who knows? Yeah, you do. So first thing we're going to do is we're going to find the cost before the tip. So here, I'm going to find the $45 plus 7% tax, and then I'm going to add the 15% tip. So I'll do this in phases. So the cost before the tip, actually, you know what? I'm going to do this a little bit more proper. So the total cost is going to be the $45, right? Plus the tax, plus the tip. Okay. Now the tax amount is going to be 45 times 7%, right, or 0.07. So what I'm going to do is I'm going to have 45 plus, and then 45 times 0.07, right? I need to multiply it by 7%, which is 0.07, to get that tax amount. So 45 times 7% is going to give me what?
Ah, come on.
There. We'll see if it gets unbearable then. 45 times 0.07 is $3.15, so 1.5. So then I'll get the paid one, but. So this is 45 plus, while I have it in my mind, 315 plus the tip. Okay. Now, what I'm going to do is I'm going to assume that I'm tipping on top of the tax amount. So to indicate that, I'm going to use brackets. Right? To say, hey, I'm going to solve for this first and then do the tip. So here I am assuming the tip is on tax as well. It kind of depends on what assumptions you're making here when you're solving this. So it's not obvious, but I'm going to tip on the tax as well. So what I have is I have 45 times 315, or sorry, plus 315, yikes, huge. 48.15 plus the tip. The tip is going to be, yeah, you can definitely, and I was going to get to that. So what I'm building up towards is 45 times 1.07, right? Which is probably a trick you use in the store when you're trying to figure out sale amounts and stuff, but definitely. But this is where it came from, right? 45 and 45, you've got that common factor, and then 1 plus 0.07. So that's why you do 45 times 1.07. Good. And then I'm going to tip on top of the 48.15, and it's going to be 15%. So this is 48.15 plus 48.15 times 15%, yep. And 48.15, I'm just going to steal it here. Oops, keep going to the wrong one. 48.15 times 0.15, 7.2225. Because we're dealing with money, right, it's 722. So 48.15 plus 7.22, which is going to be 55.37. Okay. Often, like we said, often instead of finding 45 plus 45 times 0.07, we use 45 times 1 plus 0.07, which is going to be 45 times 1.07, right? So if you're just finding out what the total price is, then you can use this little trick, right? Where you pull out that common factor and you take your price, and then 1.07 incorporates the original price as well as the tax. The only thing is, if you want to know the tax amount, then you would either have to subtract 45 from that total or do 45 times 0.07. Doesn't matter. You've got options. Okay, good. Let's see here. I've got one more example that's a little bit tricky. So, but what I wanted to emphasize here is there are lots and lots and lots of ways, maybe not that many ways, but lots of ways that you could have gone about and solved this, right? And so as long as you're able to read this and just kind of work your way to a solution. Now here, I am assuming that the tip is on the tax as well. So let's just assume that the tip is always on top of the tax amount, okay? Because that can be kind of ambiguous here, but let's just assume that it's always on top of the tax for the next question. But as long as you're able to solve this problem and get to the same solution that I found, you're probably doing it right? So try it different ways and see what works out. But let's do another example. So here, a local pub, I'll just copy it out here. A local pub has offered a $10 dinner, which includes 9% tax and a 15% tip. And just to clarify, after tax. What would the price be for the dinner if it didn't include the tip and the tax, right? So what's the cost of the dinner at the restaurant? So I guess it's a pub. What is the cost of the dinner to the pub? Okay, so what we need to do is we need to work the other way, right? Where we're peeling away the 15% tip and then peeling away the 9% tax, and then we'll just be left with the cost of the actual dinner. So what I'm going to do is I'm going to say, okay, so first from the $10, I'm going to extract the 15% tip. So from the $10, I'll take another approach where I do it less mathy and more wordy, and you can pick which one you want, but definitely try this problem on your own. See if you get there. So from the $10, I will extract the 15% tip. Okay. And so what I'm going to do is, okay, well, kind of working in reverse, and I'll use that trick where I multiply by 1.15, right? And say, okay, well, 10 is the price plus the tax, okay? So 10 is the price after tax. I'll highlight that. I'll use capital T, price after tax. So I need to work backwards, right? It's the price after tax times 1.15. That's probably the easiest way to set it up, but doesn't matter how you do it. So now I'm going to peel away that tip, 15% tip. And so now I'm going to divide both sides by 1.15. So I have 10 divided by 1.15 is the price after tax. And I've got it here, T is 8.696, so I don't run the risk of more ads. So then the price after tax is $8.69.6, so 70 cents. Okay. Because I'm doing these calculations, it's not clear to me if I should be rounding to 70 cents. So I'm just going to keep all my decimal places. And if you're ever in doubt, I want you to keep your decimal places. Right? So we'll keep all our decimal places until the end. So this is the price after tax. And so now I'm going to do the same thing where, so T, the price after tax, is the price of the dinner, which I'll call P, price of the dinner. And I think it was 9% tax. Okay, times, so P times 1.09. Okay. But T, we already solved for T, is 8.696. So what I'm going to do is I'm going to substitute that in. 8.696 is P times 1.09. P is what I'm trying to solve for. So if I divide both sides by 1.09, I get 8.696 divided by 1.09 is P. So then P, if I kind of cheat a little bit, should be 7.98. Okay. And this is the price of the dinner, 7.98. So it would be the same thing, advertising the meal for 7.98 and then plus tax plus tip. Or you could go all in and say, oh yeah, you get everything for $10, but to the restaurant, it's the same, right? Assuming you tip 15%, which you should probably.
Professor?
Yes?
Can you just explain that again? Like how you got the values?
Yes. So here, right, we started with the $10. And so my first step, so before we were given the price and then we added the tax and then we added the tip, right? But now I'm given the total price and I have to take away the tip and I have to take away the tax and just figure out what the total amount is. Okay, so what I have to do is I'm going to use this trick where instead of doing 45 plus 45 times 0.07, for example, I can just shorthand that as 45 times 1.07, and that's going to be the total amount plus tax. So now I'm using that here and saying, okay, well, 10 is going to be the price after tax, which I've just denoted it by T for tax. Can pick any letter. So the price after tax times 1.15. And then when I solve for t, I have to divide this over here. Okay, so let's do that on the side here, because maybe that's where I managed to confuse you guys. So the total cost is going to be, and maybe I'll do this down here. Whoop. Keep going. The total cost is going to be the price before, or sorry, price before, I keep saying before, price after tax. Price after tax plus the tip amount. But the tip amount is the price after tax times 0.15. So here, if I just use, I'll use this regular color. So the total cost was $10, right? So that's where that came from. And then the price after tax we're denoting by T. And then plus the tip amount is going to be the price after tax times 0.15, right? 15%. So this here, this tip amount is this tip amount. Okay. But what I've done is, and I kind of jumped there, was I said, okay, well, I can pull out a common factor of t, and this will always work, right? And so I can pull out a common factor of t and then have 1 plus 0.15. 1 plus 0.15. So that's why it becomes t times 1.15, right? 1 plus 0.15 is 1.15. So that's where the 1.15 came from, right? And the difference is, this is the tip amount, right? And this is the total amount after the tip, which is going to be equal to 10. And I'll just keep this 10 here to remind us. And then I did the same thing with the tax instead of the tip amount, if that makes sense. So then what we found was, okay, well, t times 1.15, I can solve for t, which is the total price after tax, 8.696. Right? When in doubt, keep all your decimal places. And then now the price after tax, I can whittle that down to the price of the dinner times the tax amount, 1.09. Okay. Or plus the tax amount, rather. But that follows the same procedure that we followed here. So these can be a little bit tricky, right? But once you've seen enough of them, then they're not so bad.
Okay, so while getting the tax, we again did the same thing. Like we got the common factor 1, and then we got 1.09, right?
That's correct. Yeah, so here I skipped straight to the price of the dinner, right? Plus the price of the tax, right? Which is the price of the dinner times 0.09. But what I've done is I've just pulled that P outside here, and I did the exact same thing. And maybe just to convince yourself, go through and do exactly what we showed down here, but with P instead of T. And now instead of it being the total cost, it's the price after tax. Does that make sense? Try to keep it on one page. Does that kind of jive? Looks like Logan's got it under control. It's good. All right. So we'll end there. So that's the end of chapter 1. So that's what we'll have on our quiz beginning of next day. If you choose to do it then, if not, you've got all day on Tuesday to worry about it. Any questions? I'll stop this.